Okay, in this video we plan to tackle the following problem. What is the sum of the reciprocals of all positive integers greater than 1 whose only prime factors are 2's and or 3's? So first of all, we need to look at a reciprocal, which is 1 divided by the number, or the number that multiplies by it to make 1. So for example, the reciprocal of 2 is a half, and the reciprocal of a half is 2. The reciprocal of 2/3 is 3 over 2, and vice versa. So, given all of that, we're then looking at a series which looks like the following. Half plus a third plus 1/4 plus a sixth plus a ninth, and so on ad infinitum. Now this series in itself, other than obviously the pattern in the question, doesn't have a pattern by itself. So we need to either figure out a pattern that wasn't immediately obvious to us, or split it up into two different series, and that we can do. So look at the hints if you need to, or pause now to try thinking about how you'd split it up. And the answer is that you split it up into two geometric series. So I'm going to call these A and B, and they multiply together to give us what we currently have as the series. So, clearing the page, I'm going to include one because it makes our calculations easier. This is our first series, and it's called a geometric series. Here, they're all powers of 2, and each time you multiply by half. I'm going to call this the series A. And here's the second hint, or opportunity to remember if you already know how to do it. How would you find the sum of an infinite series? Because this goes on forever. The way you do it is with a formula like this, if the series looks like this, of course, where r is the common ratio and a is your first term. So in this case, we end up with 1, your first term, over 1 minus 1/2, because your common ratio is 1/2 every time you multiply by 1/2 to get to the next term. 1 over 1 minus 1/2 is the same as saying 1 over a half, or just 2. So we know that sequence A sums to 2. Sequence B then is going to be 1 plus a third plus a sixth, and powers of, not a sixth, a ninth, and powers of 3. Because every single one of these, if they get multiplied by 1 from sequence A, they're just a power of 3. If they get multiplied by half of sequence A, they're 6 times a power of 3, or 2 times a power of 3, or whatever. If they get multiplied by a quarter, they're now 4 times a power of 3, and each time we can eventually make up every single number in our original series. And we can also add 1 to the thing. So we have 1 plus our original series is equal to A and B, A times B. So the sum of our original series is 2 times 1 over 1 minus a third, which would end up becoming 3 over 2. 2 times 3 over 2 is rather obviously 3, I don't know why I crossed that out, which means 1 plus our original series is equal to 3. That means that our original series, 1/2 plus 1/3, and so on, is equal to 2. And that's our final answer.